Okay, so in this lab, we are going to do a couple of things. One, we are going to be kind of thinking about what makes a great report. Everyone's already done a single draft, and I'm going to take this opportunity to kind of highlight some of the very relevant details that definitely should be involved. And then also, I think it's important for people to kind of share some of the stuff that is not being mentioned and figuring out whether or not that fits with a formal lab report. So in a sense, this is a writing workshop, and we're not going to cover the entire report from start to finish because that probably would take 6 hours, and we don't have 6 hours. So what the intent here is to kind of guide you into what would make a very concise, organized, logical introduction. And then do the same thing for the method section. So we're going to cover these two types of sections this time. And so the next report that you have for the next study, we will do a writing workshop for other sections. So don't only take what we discussed today and apply it to just the amino acid thin layer report. Take the concepts and the overall approaches and use it for all introductions from here on out. So we will not have another writing workshop on introductions or material methods for the rest of the semester. So this is our time to get it done and get it done right. Okay. Oops. All right. So here's our introduction. And so the way that this is going to work is everyone should have access to two things. The expectations for the report, you should have that handy. And you should also have a copy of your draft handy. And so I know that it'll feel like we're kind of working backwards, but I think that this is actually how you check to see whether or not you have the appropriate components. So what you're going to be doing is you're going to be creating an outline, like a bullet point outline based on the expectations. So if you don't remember what those expectations are, I think you should. I have them somewhere on my computer that I'm going to pull them up as well. And I'm going to have them so that we can actually talk about this. But in the introduction, let me see if I can get there really quickly. Okay. Great. Okay. So, for example, you might have one of kind of a little title that says brief background on chromatography. So I'm going to start us off so you can see what kind of notes you should be taking in your breakout rooms in just a second. So the first thing that we need to discuss is, what did we say? Brief background on chromatography. Okay. And so right? That's the first thing that you need to do. So in your group, you might say, okay, let's just do it. Let's just do one as a class really quickly. So everyone open up your chats and just tell me one thing that you think is a generalized statement about all chromatography that you find extremely valuable. And you don't have to wait to press enter, just put whatever you think. Okay. Remember, for chats, I'm not interested in copying and pasting. I'm interested in very readable short phrases that I can kind of scan. So looks like most people say something about separating compounds in a mixture. That applies to all chromatography, all of them. Great. I think that's awesome. So that's only one statement. So when we're talking about chromatography, it's called word economy. You don't need to put everything you know because everything is not important. So the fact that all chromatography is cheap and easy, is that something that you think you're going to find in a science report, like a formal published paper, because most reports, they're not, they don't care about cheap and easy. They're like, we're going to use the fanciest microscope ever, but you don't see them bragging about using a $1 million computer hooked up to a microscope. So maybe when you're deciding what approach to use, that's a good reason for you to choose it. But I don't think you need to communicate that to the scientific community unless they ask you, like, why did you choose this? Oh, well, you know, it addresses our problem and we're broke, so we had to use the cheap way. So I don't think that you need it for a report. So these are the types of things. Maybe let's see if there's anything else here. So some people are writing what an analyte is. That's great. Some people, did I see the phases? Okay. Surprised I don't see it, but all chromatography has a mobile phase and a stationary phase. I don't care what kind of chromatography you're using, they all have those phases. So since you're gonna be talking about a mobile phase and a stationary phase in your report, probably a good idea to bring it up now. Okay, so those are just a few things. Let's put that there. Okay. And anything else, make a list, because what will happen is when we come back to class, I will be adding to this, and I will be asking you to put this in the chat, and then I'll say like, hey, I didn't add that, here's why, and I will give you a reason why. So this is why you're going to use the expectations document and what you have in your own report and your collaborators in your breakout room. You will be sent to a breakout room with somebody or multiple people that you did not write the report with. That's the point of this. Okay, if you go back to the thing, the next bullet point says, provide a brief but a bit more depth on TLC. So then that should be your next section. Okay, so we say specifically TLC, and then you have a couple bullet points. And then you have a little bullet point list of this. Now, if this is, I doubt many of you use this approach when writing your draft, but this is the approach that I encourage you to try for the next round or for the next revision or for the next report. Okay, so use the expectations doc like we're using it right now to create your outline, and then make that outline into a draft, and then revise that draft. Okay, so you're going to do this for the introduction, and you can see here that this should be 1 to 2 paragraphs, depending on how much information you have. I can kind of guide you and tell you like, yeah, if you're going to add all this stuff, it probably should be 2 separate paragraphs, and you're going to start thinking about your topic sentences. Okay, so it looks like in this first paragraph, you're going to have a brief background in chromatography, depending on how concise of a writer you are. Next, you might say that you need a transition statement. So essentially, how do you go from talking about general chromatography, and now you're smoothly going to transition into thin layer chromatography? So you need to input a transition statement here. What is a sentence you can write that would say like blah, 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 chromatography, 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 and then somehow you want to smoothly lead the reader into, now you're going to start talking about TLC. Okay. On that same note, you need a topic sentence. What is one sentence that can be used? What is one sentence that can be supported by all of the things underneath it? Okay, and so, yeah, I know this is not English class. I see it on my evals all the time. She teaches this like it's English class. I'm not, but communicating scientifically still requires English grammar, and the typical things that you would find in an English paper need to be brought in here. Okay, so all of these are going to need a topic and a transition statement with the individual ideas in between. Okay, So after you talk about TLC, you go to the next 1 or 2 paragraphs. It looks like the 1 or 2 paragraphs are going to be about the learner objectives. So maybe that's your 3rd paragraph. Okay, so topic sentence and transition statement, and anything else, we're going to have details here. So don't just say, oh, state the learning objectives. Actually write in your document how you phrased the learning objectives, or, you know, write them in note fashion, like relationship between. So don't be general here. And this is going to matter more when we get to the methods. When I ask you for certain methods, you're not going to just tell me, oh, we put the temperature and we put the volume, because I'll say, what was the temperature? What was the volume? So that's why you need your draft with you today. So in the first breakout room session, you're only going to do the introduction. Okay, and create something that looks like this. We'll come back as a class. We'll fill in the class version of it. And then we'll do the same thing for the methods and materials. And then we'll go. Okay, questions? All righty. So all right, so there's gonna be 3 to 4 people in your room. Let's do 25 minutes. Hold on. Yeah, I think 25 minutes for this. And if you feel like you're done early, you can start creating a similar document for the material and methods. Okay, so 25 minutes, we'll be back at 11:55. And I will be here fumbling around with my computer. And I will not log off. So if in some crazy event you get kicked out of the Zoom meeting together, you should have everyone's information, but I will get back on as soon as I can. So worst case scenario, just try to log back on at 11:50. Sorry, 10:55, 10:55. Yes, 10:55. Thanks, Nathaniel. Okay, I'll see you soon. Okay, let's see here. So I took the time during break to copy this onto the Notability app, because I feel like that allows me to be more successful at taking notes for the class. So we are back. You just spent some time in your breakout room talking about basically building an outline for the introduction based on what you have written, what you think belongs there. Maybe in talking to other people, you're already figuring out stuff that you should have included, or maybe stuff that you should delete. So essentially, we're just going to combine everyone's thoughts onto this one electronic piece of paper, and we're going to go from there. So everyone should have their chats open, please. Okay. And we'll get going. So for general chromatography, I would like, so this is going to be just, there were 6 breakout rooms. Okay. This first one is for everyone because this is basically the topic of this is the first sentence of your entire lab report. So what is the topic sentence that you would use for a paragraph about general chromatography? Please wait to press enter. Go ahead and type a topic sentence in now. If you did not come up with one, you need to come up with one on the spot. Okay, please press enter. Okay, so this looks really great. Most people, and so I'm not saying that if you didn't write this, it's wrong, but I'm just going with the general population here in class today, actually took both of these ideas and created a topic sentence with those details. And that's absolutely okay. That to me tells me that the paragraph about general chromatography doesn't actually have to be an entire paragraph because you took the two most important details and you carefully constructed them into a topic, most people, concise sentence. And there's not really much left to talk about with regards to general chromatography. But just in case there are things that you have, at this point, you don't have to wait to press enter, but everyone should be prepared and following along. So everyone, we're talking about general chromatography. You're in your groups, you have your document open. Just go ahead and start typing in some of any other information that you included in your draft or that you think you should include in your final draft that pertains to general chromatography that we have not already put on this piece of paper. So go ahead and start entering things in now. Okay, so I see vague things. So saying that there's different types, what do you think the next question I'm going to ask is? And if you guessed, what are the types? You are correct. Yes. Okay. So there are different types that include, so instead of saying there are many different types of chromatography, some of these types are, you can just say there are many types of chromatography, including. You've taken two sentences, squished them into one. Okay, including paper, gas, thin layer. I would always limit your list. Remember, more is not better. A list of 300 types is not any better than a list of 2 to 3. The most important thing about the list that you do include is that you have the thin layer type on there, since the entire report is going to be about thin layer chromatography. Okay. Okay, so other people are saying you have defined, okay. Cool. Defined the 2 phases. What do those mean? So I think that's actually pretty good. So you want to define both the mobile and the stationary phase. So the topic sentence just tells you, hey, in general, this is what chromatography does by using a mobile phase and a stationary phase. That should naturally lead you into talking about what the mobile phase is and does, and then the stationary phase, what that does, what that is and does. And then maybe you say something. The order of these really is up to its writing style. So how are you going to get to the next idea? Okay, so let's see. I think we covered all the stuff that you added. Okay, so now please do wait to press enter, but go ahead and type your transition sentence in. How do you get from talking about general chromatography to thin layer chromatography? Okay, what do you have? Go ahead and press enter. These are good. Okay, so I'm gonna kind of, again, just kind of take bits and pieces of what everyone is contributing or what a lot of people are contributing. And it looks like most of you are talking about how there's different types of chromatography. One of them is thin layer chromatography. And then you have something about thin layer chromatography, specifically separating things by polarity, something about TLC and polarity. So the transition statement for one paragraph or one kind of topic sometimes is pretty similar to the topic sentence for that next paragraph. So it's just, you have to be really careful about not sounding like you're saying the same sentence twice. We are not yet talking about the study at hand. And then this is also a good time to remind you, you're not calling it your experiment, doesn't belong to you. You want to avoid phrases like our learning objective, our research objective, our experiment, or the objective in this experiment. Those phrases don't show up in formal reports. You just say, here we investigated blah, blah, blah. That's it. So maybe if you want to start with TLC will be used to investigate the polarity of certain compounds, but that kind of takes you out of order because you are not really talking about that till the very end. So you can say something about the different types. And so here's what I'm going to do is this might be used to write your transition sentence. And I think most of you kind of alluded to that, which is totally fine. So it looks like you have a sentence here, right? This is a sentence. Maybe a couple sentences here, one to define the mobile phase, one to define the stationary phase, and maybe something else like, oh yeah, okay. Anything that we haven't put anything, so I don't think there's anything else that you're gonna put there. And then you can kind of talk about the different types of thin layer chromatography and how that last specific type separates compounds by polarity. Okay, great. So in my opinion, this could be a very concise, short paragraph. And when in doubt, you should opt for short paragraphs rather than long paragraphs. If this topic sentence, if you can see it here, this is fully supported by everything below it. So this would make a perfectly reasonable paragraph. Okay, so great job. Now we're just going to do the same thing for thin layer chromatography. So at this point, please don't press enter. Go ahead and write your topic sentence for thin layer chromatography. and go ahead and press enter. I just entered that into the chat so that I know where the distinction between ideas are. Okay, so for those of you that have your topic sentence describing that TLC separates by polarity, that's fine, but make sure your transition statement doesn't also say that. So you can't say the same thing twice, because then I'll write, there are parts that are redundant, and you can see how that is redundant. The previous sentence saying TLC separates by polarity, then the next paragraph saying TLC separates by polarity. It's redundant. So not to say including that is wrong up here, not to say including it is wrong down here, but just make sure you only do it once. Okay, so I'm going to go with what we have on this sheet of notes. And so it looks like most of you are kind of describing a little bit more about how the TLC, or like specialized reagents that are specific to TLC. So reminding them it's a type of chromatography, that's okay. And okay, you're going to say something about the solvent being less polar. Yes. I would not, if you're going to go through the trouble of defining mobile and stationary phases, I would avoid using the word solvent, at least in the introduction, and you want to probably call it the mobile phase, right? Because you just went through the trouble of saying like, hey, all chromatography uses a mobile phase and a stationary phase. And then once you start talking about TLC, you're saying, and the mobile phase for TLC happens to be a less polar solvent, right? You can talk about it like that. Whereas the stationary phase, so you're just defining them. Now you're defining them specifically. Up here, you defined them broadly. It's a template. You just be consistent. Now down here, you're defining them specifically. Now, if you want to provide a list like could be this or this, just make sure you finish with the stationary phase that you're going to use. So, because I think some people did start listing some of the different, I think, did I see that somewhere? Guess not. Okay. Oh, a medium coat. Okay, okay. Okay, so medium with high polarity. Okay. For example, silica coated aluminum foil. Perfect. And now what you're doing is you're setting yourself up so that the reader knows essentially this is the one that we are going to be using. Okay. So the stationary phase that you are using is the silica on aluminum foil. Okay. And if you're going through that trouble, maybe you write the mobile solvent here. Okay. Nice job, everybody. Okay, what's some more information, bullet points that you have about thin layer chromatography? Don't wait to press enter, just keep entering them one at a time. Avoid blocks of copy and pasted text, please. Just phrases. We're trying to build an outline, not a essay. So information about TLC, anything that you can think of in phrases, please. Okay, so I'm getting a lot of kind of generalized words rather than phrases. So just to remind you, I'm just reading this straight from the expectations, but a bit more in-depth background on TLC. So first thing is the general purpose. Okay, so we've kind of already covered that, right? We covered it in the transition statement that TLC is going to separate compounds based on polarity. So that's the general purpose, how it works. So the brief. So briefly, how does it work? And we've already started to talk about that. Briefly, you're going to use a mobile phase that is a less polar solvent and a stationary phase that is a solid medium coated. So people know what I'm about. A solid medium, not like medium in terms of like high, medium, low. Medium meaning like a solid thing that is coated with some kind of very polar substance. For example, a stationary phase that can be used is silica coated on aluminum foil with the less polar solvent 4 to 1 to 1, whatever. And then the expectations say how the data is generated. So nowhere do I see how the spots show up. I see the RF, that's the data that you're going to make, but none of that's going to happen without talking about how you get the data in the first place. So if it's not in your draft now, you probably need to, I think somebody did write it. So I think I'm going to give them props. Shout out to Ella, good job. How the spots are visualized. So then my question is, how are the spots visualized? And then another shout out to Carla, visual indicator. So my next question is, that's vague. What is the visual indicator, or what are some examples of visual indicators? Okay. So something about the data being analyzed using a visual indicator, like maybe you use a couple of examples, or maybe you just provide the one example that, oh my God, that you actually are using too. Okay. So that's how you get the data. Once the spot has appeared, then you calculate what the RF is. So we're doing it briefly. This is not the method section. We do not need to be talking step by step by step by step by step. We're going to do that in the next section. Here we just need to say like, hey, we're using this mobile phase, or here's a mobile phase that can be used because it's less polar than this stationary phase. Once the experiment is done running, the data is visualized using something like ninhydrin. And then to analyze the spots, you calculate the RF. Okay, which is, then you define the RF. Okay, straight from the expectations doc. Finally, and so maybe this is not in the right order according to how you're writing, but one of the other things you probably should include are like, what are some of the specific research questions a researcher would be using TLC for? And again, it's all a template. If you're going to provide 2 or 3 examples, the last example better be the example that you're actually using TLC for. That's really the way you like, hey, the last little idea that I give you, boom, that's what we're doing. Okay, so having said that, just come up with 2. One's easy because one's the one that you're doing. What are 2 research questions that a researcher would use TLC to answer or to address? Great, nice job. So I'm going with what Trey just wrote because I think it's pretty concise and to the point. So some of the reasons that are also relatable to this study at hand is to essentially identify the compounds in a solution. And by doing that, you can make a conclusion about the purity of that substance too, right? So it's kind of like a twofold. You can't determine purity unless you first identify the composition. So you can identify the composition. Identifying the composition means not only do you identify the thing, but how many of those things are in there, right? So number and the actual ID of the compound. By doing this, you can make a conclusion about the purity of a sample. For example, a compound that is a mixture that's composed of several amino acids, right? Because it doesn't have to be amino acids. Like thin layer chromatography can be used for other, it doesn't have to be a protein mixture, it could be other things. Okay, so great job. Next, nice, Luis, let's use analyte since we've already used that term before and it's most specific to this study at hand. Yes, let's say analyte. Last but not least, transition statement or sentence, I should say. Go ahead and wait to press enter on this one. Go ahead and type it in. The transition sentence. So getting from thin layer chromatography to how we're going to start talking about learner objectives. Okay, enter please. Okay. Oh no, why? We're all having computer problems today. Okay. Yeah, get your laptop fixed. Okay, looks like people from one group have entered their transition sentence. So I'm waiting for 5 other groups and about 13 other people. Okay. So just like piece of advice, when you're thinking about a transition statement, it's almost worthwhile to think of the topic sentence first. Like how are you going to open the next paragraph? So if you're going to be talking about learner objectives, so I like where some of you are going. Some of you somehow squeezed in molecular weight. You squeezed in the concept of hydropathy. And why did you do this in your transition statement? Because the learner objectives have stuff to do, they revolve around those ideas. So the transition sentence, if you're going from just general TLC, like not everyone is using TLC to, study the relationships of increasing molecular weight. People have a variety of different reasons they would do that. But you're just mentioning to the reader like, hey, not only does this work because molecules have different polar properties, but this approach also lets us make conclusions, allows us to make conclusions, or allows an analysis. Make conclusion or allow analysis of what? Of properties, including hydropathy, right? Because if I asked you to, if I said like, hey, not only do I want you to identify the 4 amino acids that compose this supplement, but I also want you to make a conclusion about the overall polar properties of this solution. If all 4 of them are polar, you would say, yes, this is a polar, likely hydrophilic amino acid supplement that people can take for muscle atrophy. Right? Or maybe it needs to be paired with some kind of like fat soluble. You can say water soluble, fat soluble. So you can make conclusions about the samples you're analyzing. You can make conclusions about their hydropathy, their solubility, and that is important if you're trying to generate drugs. Can it actually get into your cells? Because if it can't, what's the point? It's not absorbed, just pee it out. Okay, great. And I think that's enough of a hint, enough of a clue that will lead us into the learner objective paragraph. And so this really has to be, it needs to follow kind of like, it's kind of boring. Like if you read enough science papers, you see that everyone writes the same way. They state their objective, they state their predictions, but not like that. They don't say our objective is, our predictions are, our outcome. They just say, here we investigate the relationship between this and this and predict to see blah, blah, blah. The data suggests yada, yada, yada. And it's the same thing, just kind of switch around the words just a little bit so that it doesn't sound like a robot is talking every single time. But that's essentially what it is. So topic sentence. So everyone please go ahead and type in the topic sentence for the paragraph about learner objectives. And please go ahead and press enter. I see phrases and I'm going to say delete. Delete the phrase in this experiment. It is our study, blah, blah, blah. It's not yours. Just delete that phrase. Delete we were interested in. You start with, to determine the relationship, comma, we used this. Okay? To study the relationship between blah, 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 we used such and such. Okay. The purpose of the study, delete it. Start with, to develop a protein supplement, comma, we did this, right? So some of you are starting with one of the research objectives, the learner objectives. You're starting with just looking at polarity and RF. That is not a great topic sentence because you're going to have information about molecular weight and hydropathy. Those would not support the topic sentence. So the goal here is to come up with a sentence that all of your supporting sentences would support, or yeah, they would back it up. Okay. We're not yet talking about the research objective. So if you're starting to talk about making the protein supplement, that's not part of the learner objectives. That comes later. So I think that, Caleb, I'm going to mostly use yours here. So thank you. So everyone, if you can kind of look at Caleb's topic sentence, there are multiple relationships between amino acids and their properties. Okay, we're going to tidy this up. It's a little bit long, but I think that that is something a little bit general, but it still can encompass, it can encompass the traits that we're going to look at. So the topic sentence will have something about multiple relationships or traits, right? basically what I am interpreting is that there are multiple relationships between molecular property and the molecule's ability to travel up the plate. So I'm going to put phrases here, and then I'm going to let everyone kind of reword things how they see fit, because this is not me writing your drafts for you. Molecular properties and the ability to travel. You might want to, let's see. And I think for a topic sentence, you want to try to be a little bit more brief here. Okay, so notice I didn't also put in hydropathy. Why? Because we stated it earlier. Also, because we're really not looking at, yes, indirectly we're looking at hydropathy, but directly we're looking at the change of molecular weight. And we just happen to categorize the amino acids first. Polarity, we really are comparing polar to non-polar. And you definitely want to bring in that idea of RF again. And I think that can very easily be done in a single sentence, a single concise sentence, to avoid the going round and round and round to describe the same thing. Okay. So those are the things I think could, it's not the only correct, proper, amazing topic sentence that can be written, but I think that's a good start. Okay. And you can even just look at, you don't have to read the words, but just look at the length of some of these supposed topic sentences. I guarantee they're probably run-ons. You know, things that are like 7 lines long, it's probably too long for a topic sentence. Okay. All right, great job. So we don't need to spend time going over the learner objectives one by one. We did that last class. So I'm not going to waste time doing it again today, but I do want to present maybe just one example of how we can talk about the learner objective and then kind of smoothly go into the next learner objective. I think it's pretty clear by now that 2 of the objectives are kind of grouped together and the other 2 are kind of grouped together. So you can kind of talk about them like that. So we know that info. For example, one relationship we investigated, right? That's your opening little sentence for going from your topic sentence to the actual meat and potatoes of this paragraph. For example, we investigated the relationship between, or the impact, the effects. The effects. Grown-ass adult, I still have trouble with effects and effects. Effects of polarity on RF. That's what you're trying to study. Not one of the learner objectives is remove that phrase from your vocabulary. Get it out of it. For example, we investigated the effects of polarity on RF. You can use we, right? But you're not owning it. You're not saying our predictions, you're just saying we predicted. So that's an active verb tense rather than owning. You're not taking possession of it. So we predicted whatever you predicted, right? And we went over this last week. It should be something along the lines of molecules that have a higher, that are more polar will have blah, blah, blah. because whatever rationale you have, and then you'll have some kind of reference. Avoid using slides from lecture. You can use the manual, but that's not the original source. I am not the inventor of the first scientist that realized that polar substances have a high affinity for other polar substances. There are published works out there that you can definitely use. And then the next sentence is no, not our, even I do it sometimes. The data indicated, suggested, showed, demonstrated, anything like that. Supported these predictions. Interestingly, the data did not support those predictions, and instead it showed this. Okay. We sought to also investigate the effects of polarity on the color spot that would develop. And then you do the same thing. So you can say, so instead of just being like very robotic, you can say another example is, you can say next, or we also, or in addition. So some kind of phrase here, and I'm going to put it in a different color. Phrase that kind of makes it sound like a story rather than a bullet point list. Okay. But it's the same recipe for every single learning objective. So you finish all 4. So at the end of this paragraph, the scientist that's reading your paper has a very clear understanding of the relationships that you are going to provide a conclusion for. Not only that, you did provide the conclusions for them. Okay, last but not least, transition sentence. So hold on, you can start typing it. Please don't press enter, because the last major topic of the introduction is going to be the actual research. You always want to end the introduction with the big take-home message. Like, what's the big issue? What's the big problem? How did you use it? What did you find? So, research objective, predictions, why, takeaway. Like, but I don't want to tell them. I want them to read the rest of it. They're not going to read it if you don't tell them what they're going to read about. Okay, so now transition statement. Keep typing. All right, enter. Okay, so the things I'm seeing here so far, definitely talk about the protein supplement, but you're missing the link. So it's like some of these sentences that are being entered into the chat are only talking about the protein supplement, but you forgot to link the learner objectives to them somehow. So now it sounds like 2 different studies, 2 different paragraphs. So I think there was a few things. think we can do a good job of linking this if I combine a few of your contributions here. So you somehow want to come up with kind of like a summary of the above information. And so I like that's when, who said this? Layla said, by observing the properties, not of each molecule, but by observing these properties, right? I don't think you need to list them again because you just spent 4 sentences talking about them. Or by gaining a better understanding of these relationships or something like that, you are then able to, so not how you would write it, but I'm just talking to you about it. It's like, by understanding these relationships and getting a better idea for how this works, you can in fact use that knowledge to even more confidently identify the compounds in a protein with unknown composition, right? So that's the whole point of this. So in a sense, you are taking what you just learned about these relationships, and then you're going to use that to investigate a protein supplement, a composition of a protein supplement. Maybe we say something like, using your previous knowledge to analyze the composition of maybe complex mixtures. Because that will indicate, because before you're just looking at single individual amino acids one by one, and here you're using that information so that when you do have a solution that has more than one of those samples in it, you can actually make a pretty good conclusion about that mixture too. So to analyze the composition of a complex mixture, and then here's where you might say, such as a protein supplement for muscle atrophy. Okay. So having said that, you haven't yet put your name in. You don't have to put it in now. I'm gonna wait till I see the drafts for real so that I can smile at home when I have to grade stuff, okay? So don't tell me your names now. But this really nicely leads you to the actual research goal, right? The research study. And this is when you're going to, you don't have to tell me your topic sentence because pretty much everyone is going to have very similar things. But the topic sentence should be something along the lines of identifying the compounds and purity of the such and such named supplement that you and your team came up with, using, even though we've been talking about TLC the whole time, you want to make sure there's no questions about it. Keeping in line with the same exact template as up here, where you have the objective that ended up being the topic sentence. So some of the supporting sentences is now you're going to talk about what you predicted it should have, and then your overall outcome. So you can say, here's where you're going to have your 4 amino acids. We predict this supplement to contain blah, 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 blah. And then some kind of descriptive word if you concluded that those were the 4 amino acids. It's a very simple, we predicted it would contain alanine, aspartic acid, this and that. The data suggests, in fact, that, atrophy be gone is ready for the next phase and is composed of these amino acids. Boom. I didn't see anyone that got all 4 of them. So the conclusion should be unfortunately, or surprisingly, or disappointing. Maybe you don't want to say disappointingly, because that indicates like you're sad with your science. But you want to just say something that at least provides some kind of clue as to whether or not this data is favorable or not. Okay, so what was the outcome? So use a descriptive word here. Most people just use, if it did work, indeed, comma, if it didn't work, surprisingly, you're not sad, you're just surprised. Okay. Selling your science is a skill all in itself. Okay. And so that last sentence, I mean, that last paragraph even, it's optional. Depends on how well you write. If you're a very concise writer, you can potentially stick this stuff into the same paragraph. If this already is taking up a big chunk, I don't know, maybe just add another 1 fluff sentence, just 1. You know, you can come up with something that relates to the research objective. So it's not just 2 sentences, right? You want to make at least 3 sentences for the final thing. That's it. Okay. Yeah. Okay. Sadly, Johnny now has no job. Okay. So there's your introduction, your notes for your introduction. And I hope that they help. And just yes or no? Do you think that this has now given you a lot to revise your, like, do you have a lot of revisions, or your introduction's like ready to go? On a scale of 1 to 10, 10 being an A+ introduction, 1 being you didn't do it. How rate your introduction before this workshop? It's going to take some bravery. Okay, so before the workshop, we're thinking like 6 to 7 points out of 10, 5 points. Okay, great. Not to toot my own horn. So you don't need to tell me, but what this tells me is that there are definitely things that can be revised, and they should. Hopefully this provided you with some ideas on how to organize your thoughts a little better, how really topic sentence and transition sentences are very critical to science writing and actually provides the flow of information. So it's not just like ideas floating around on a piece of paper. It really is a story. And like an English paper, it starts really broad, general chromatography, starts getting narrow, TLC in general. Oh, and then this is how we're using TLC. And here's how we're using TLC. Here are the things that we're going to use TLC for. So it starts broad, narrows down, and then the next part is going to be, you end with like the boom, the fireworks. This is our take home message. Like, so interested in reading, flip the page. Okay, so that's your intro. Come back here. We're going to do the same thing, building a outline just like this with the material and methods, but this takes a lot. It's a lot of thinking, a lot of writing, a lot of typing. Okay, so I think we should take a break. So when we come back from break, we're going to hit the material and method section, and this one really takes details. So I'm going to, hopefully it works when I come back. Okay, let's see. So you can even start doing this if you want. This is the section we're going to talk about. And an example of preparing the developing tank. Look back to your notes from last week. We actually wrote this stuff in our class notes, in a very brief description of the chromatography chamber. So when I say things like approximate height, I don't want you to type in the height. I don't want you to type in chamber details. I do want you to type the words, a glass chamber that, I don't know the dimensions off the top of my head, but like 30 by 10 by 50, centimeters. I want that level of detail rather than just say the measurements of the chamber. So is that what you have in your report? Measurements of the chamber were recorded? No, you have the actual information. So that's what we're going to put on this piece of paper. Okay. 11:49, let's be back at 12. I will, at 12, we'll just meet so that I can send you to your breakout rooms, and then you'll go to your breakout rooms. But I really do want you to take a break. So get water, walk around your house, do whatever, you know, play with your animals. I don't care. But we'll be back at 12. All right, at your breakout rooms, each room came up with a list of phrases, details, information that is necessary to write a concise but informative material methods section. So the first paragraph, and you always want to write the methods in chronological order. Now, sometimes that doesn't mean the way in which it happened in the actual lab, but if you had all the time in the world and could sit around and just like wait until the TLC sheet was dried and you'd have to do nothing during that time. So you don't want to write your method section with things like, meanwhile, our other teammates did blah, blah, blah. Just write them one at a time. Pretend time is of the essence, right? So you just take however much time you want. All right, so setting up. Totally up to you and your group. You can describe how the chamber was set up first, or you can describe how the TLC sheet was set up first. Either way, doesn't matter. They both have to happen before the next thing happens. So in this case, you can just choose, doesn't matter. So for the sake of, instead of, you know, saying like, how did you do it? We're just going to start with setting up the chamber, okay? So chamber setup. Okay. So under chamber, now we go in chronological order and include all of the important details. So as I have this expectations document out, please, you don't have to wait to press enter for any of this stuff, but I do expect everyone to start contributing. Remember, it's up to you. The longer you take to contribute, the longer we're all here. So go ahead and press details about the chamber. So I need you to listen to the directions. I just need information about the chamber, okay? I'm getting stuff about the solvent. We're not talking about the solvent. We're talking about the chamber, okay? The fact that it's made out of glass, the fact that it's 30 by 10 by 14. Okay, that it has a lid. These are all great. Okay. Great. Where is the chamber kept? Where are we doing all of this at? Great. Notice I'm not asking why at all. I'm just asking the what's. The method section is pretty much the what's. Great. Fume hood, there's some more important information here. 26 degrees. Great. Okay, great. That describes the chamber. DXN is description. All right. Now, how do you prepare the chamber? So what do you do to the chamber? Now, any specific details that relate to that, even if you've already put it. Okay, so some of you are writing directions. You're writing in the, I don't even know what the correct tense is, but you're telling me to add. You're not writing directions for someone. You are not telling me to pour. That already happened. It actually happened. You saw me do it in the video. Yes, okay. So 48 mils of, everyone's putting this, was poured into see what I'm going to do here. Okay, we just took two separate sentences, or maybe you have 3 or 4 sentences and we made them one. 48 mils of a 4:1:1, blah, 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 blah. Here's where you can say in parentheses, mobile phase. Why do we write mobile phase in parentheses? Because it's the less specific phrase that you can use to describe what you're actually pouring. Is it important still? Yes, but it's less important than actually saying the name of the reagent. 48 mils of 4:1:1 such and such, mobile phase, was poured into a 30 by 10 by 14 centimeter glass chamber with a lid. The chamber is placed in the fume hood at 26 degrees. Boom, done. If you have a method section that is more than 1 page, double spaced, you need to cut stuff out and you need to trim stuff down. Okay, so other people are writing a paper towel was saturated and then slapped on the wall. Okay, there's a very easy, quick way to say that. So if you're gonna include it, make sure it is a phrase and you're not explaining why. The extent of explaining why would be, here, I'll give you an example. To maintain humidity. In case people are like, why is she sticking trash in there? Okay. To maintain humidity, something about your wet piece of paper towel. That is it. We're not explaining why humidity is important for thin layer chromatographies to work. We're not explaining how when you put it there, it prevents the solvent from evaporating. We're not saying anything else. This is the extent, phrases like this is the extent of explaining anything in your methods. Don't defend yourself. Just tell these people, this is what happened. That's it. You don't have to defend yourself. You don't have to defend your choice of certain things. You are a scientist. You've thought through this. You've looked at all your options. This is the one you chose. If someone doesn't like it, they don't like it. All right. So let me go back to this thing. Okay. We got the important information about the solvent. Somebody else put something about the solvent that I liked. pH of 3.5. You do not say the pH was recorded. Those are needless details. A scientist knows how to record a pH. There's different ways to do it. We have the, the cheapo strips, but fancy labs have an actual machine that you just stick a probe in, bing, digital 3.5. Okay. And the correct way to annotate pH is simply after the reagent's name in parentheses, you just write pH 3.5. You don't say the pH is, equals, nothing. Just pH space 3.5. Okay. Is there anything else that we want to figure out? Sometimes I miss things, so it's not like a test. It's not to put you on the spot. Is there anything else that you think needs to fit under chamber setup that we haven't yet discussed that maybe we need to put on this list or not? Okay. Let's move on. So you don't need to say anything about the lid. No, just say the glass chamber with a lid. That's fine. Okay. I want everyone to look at the way that we wrote down the information for the chamber. You're going to use that same idea when you write down the information for the TLC sheet. So what did we do here? We said the amount of something that was added to the chamber, right? And for the chamber, it was poured. Things are not being poured on the TLC sheet. You can just say added probably, but there's a certain amount, a certain concentration, a certain name of reagent or reagents, okay, was added to, and then you describe the chamber. So maybe you want to describe the TLC sheet and indicate that it's the stationary phase. So at this point, I'm going to do the description of the TLC sheet. We're going to write it down first, but it's going to end up being second on our sheet of notes. So for now, what are all the important details about the TLC sheet itself? You should really just be using what's it made out of, what's its size. Okay, it's not made of glass, but it's a silica gel. Here's where you use the actual product name. Okay, so I think this is silica gel on aluminum. I'm writing abbreviations. None of you should be writing abbreviations in your method section. Okay. So thank you, Nathaniel, and whoever else is writing it in this same fashion. When you are using a store-bought, a company-bought product, here's how you have to write it in the method section. You write the official product name. So whatever was on the sticker from the company, that's what you would call it. A silica gel, and we even can say 20 by 10 centimeter. Silica gel in aluminum foil, exactly as Nathaniel has it. That's how everyone should have it. So you have the vendor name, which is Sigma Aldrich. Okay. Then you have the catalog number, which is whatever. And then you also have the product number. Sorry, the product number is the catalog number. So you just have the catalog number. Okay. And this is important for not only this study, but future ones. We use a lot of things that are store-bought. And from this point forward, you're expected to write it in this fashion. Nowhere do you see that was purchased from Sigma Aldrich and has the catalog number this. That's too much word. That's too many words for a method section. By writing it in this fashion, you have provided the scientist every single piece of information. By writing this, every piece of information they need. They can simply go to the Sigma Aldrich website, look up this catalog number, and order it themselves. Fewer words for the reader, the better in the method section. Okay, so you've described the TLC sheet. And so in line with what we did up here, let's start with this. What is the volume of reagents that you added to the sheet? You added many reagents, but what is the volume? 3 microliters. Okay. Now, 3 microliters of what? The way that we wrote it up there is we wrote the concentration. So what was the concentration of the stuff that you added? Okay. So here's where it's going to be obvious if you've used the additional resources that I have given you. Were all of them at 1% weight by volume? Okay. So I posted, there you go. I posted a table for everyone to look at that had not only the order of the amino acids as they appeared on the sheet, but also the concentrations of them. So yes, most of them were at 1% weight by volume. Some of them were at 1.5% weight by volume, and some of them had an additive in them so that they would actually dissolve. So you need to somehow fit all this in. So you can say 3 microliters of 1% weight by volume amino acids were added to, then we already have it built in, a 20 by 10 silica gel and aluminum foil vendor catalog period. And then here's where you have to kind of like, you have to state it. You have to state it here. You can say for whatever amino acids, for, I don't remember how many of them off the top of my head, but let's pretend there was 2 of them. And you write their name. So this is a name of an amino acid. This is a name of an amino acid. And let's say there was 3. For valine, leucine, and lysine, 1%, 1.5% weight by volume was used. And if there's any special other things, you want to just repeat that. Okay. Any other special samples, right? You're going to write that. Okay. But you didn't only just do the amino acids. Right? What else did you add to the sheet? What's this whole thing about? Okay. So you did add, or I did add 3 microliters of the protein supplement sample. So it doesn't really fit the way that we've written stuff. So I would write it right here. 3 microliters of the protein supplement and 1% weight by volume amino acids were added. Keep going. But this is where you're going to have your special protein supplement name. And that's it. 1 to 2 sentences describing the TLC sheet, and it's prepared. Okay. Not done. Couple more details. Samples were added. Now we're going to talk about where or how. Okay, so we've talked about like how much and the concentration of them. So what are some key phrases about, what do you think the important things are that describe how I put the spots or the samples on the sheet? Okay. Good. Okay, so the samples were added equidistant or evenly spaced, evenly distributed. Great. So let's write that. That's important. You have this key phrase that you're using, or some of you are using, in the line of origin. I have no clue so far where this line of origin. Oh, yes, Kelly, thank you. So samples were added approximately 1 centimeter from the bottom. Approximately, you're going to write that. The word out. Abbreviations for class, full words for reports, except for units. So you can actually write ml. You can actually write ul, and you should. Centimeters, write cm. Do not write the word centimeter. Approximately 1 centimeter from the bottom at the line of origin. Great. Now, some people are saying that you pipetted them. Nah, it's implied. So that's something that a scientist was like, yeah, no kidding. I got to use a pipette. So yeah. So we don't really say pipetted. The same way we didn't say use a graduated cylinder to measure 48 mils and then pour it in the chamber. It's pretty common knowledge that you're going to use a graduated cylinder to add this small volume. It's pretty common knowledge that you're going to use a pipette. But you being a new writer, you may not know that that's the point of the workshop. Okay. That's it, right? And that's the only important marking that needs to be there. So you can even say approximately 1 centimeter from the bottom at a, oops, demarcated, traced, marked, doesn't matter. Noted, yeah. That's it. Okay. So if you imagine this happening, you can imagine you have a bunch of samples. Maybe you have 20, right? Because there are 20. The 20 amino acids, you have them equally spaced apart. You also know that you have 3. I'm envisioning this as we're going through it to make sure that we have everything. They are all evenly spaced apart. They're about 1 centimeter from the bottom of the plate. You also put your protein supplement. If I had to do this, I'd be like, okay, cool. Well, these people used 1%. They got results. Cool. They have to use a special concentration and some other kind of little salts for these ones. I'm going to do the same thing too. Okay, great. I know the special like samples that I have to monitor. All right. And the last thing that you're going to do is the TLC sheet dried, right? So the TLC sheet dried. You can alternatively say the spots dried, whatever, right? But that's essentially what's happening. So here's another phrase, get it out of your head and out of your vocabulary for science class forever. The TLC sheet was not allowed to dry. You did not give it permission. It did not ask you for permission. It was going to happen regardless. So no, allowed to dry, allowed to. Nothing is allowed to. It happened. That's science. Whether you want it to or not, whether you give it, sign the permission slip or not, get allowed to out of there. I know some of you have it. I see it every single semester. The TLC sheet dried. What's important about the drying? Like, are there any important details we need to know about drying? If so, put them down. And the clue is you're drying a couple different things a couple different ways. So it's probably best to describe how this thing is drying. Okay. Okay. And this is why I wanted to do this, because this is not the part where we're using the hair dryer or the incubator. Air dry. Yep. Air. Air can be a lot of different temperatures. So 50 degrees, if 54 degrees is not right, what is right? Room temperature. So I can't recall if I measured the room temperature. You have to look back at the video. I will look back at the video later. But if I did mention some kind of temperature in the ambient lab, that is the temperature that you should add here. If I didn't, then you can write RT as opposed to whatever the temperature was, or that's a very common abbreviation for room temperature. So you can just write RT, okay, for however many minutes. And it doesn't have to be exact. So anytime you don't have an exact value, you write approximately. When you do have an exact value, you do not write exact, you just write the number. So maybe you need to write approximately X number of minutes. Okay, now that sheet's dry, the chamber's already ready for us. We're good to go. We can go ahead and get started. So next on our list, running the experiment. Running the experiment. And I give you some information about how you should start this. Chronological order. So if you're going to run something, you got to start it. Okay, so I give you your first sentence. Once the TLC sheet was dried, so you can say, that's as transition-y as we're getting. The dried TLC sheet was placed in the prepared chamber. And it's okay if everyone's first sentence looks like that. There's only very limited different ways to describe that, but you're more than welcome to try to come up with your own phrase and your own words, but that's pretty much it. Okay, so according to the expectations document, we need details like the entire runtime, the temperature, and where the solvent started and ended. So now it's your turn. Give me all the details you think. Go for it. How did we run the experiment? Any details you think is important, we'll organize them on our sheet of paper. Okay. Okay, so people are saying 95 to 100. Did I not specify in the video? If I didn't say an actual time, oh, there's some discrepancies. Okay, I said, okay, so if I said 95 to 100, we usually don't have ranges in methods. So you can just say approximately and then choose one of those. 95 minutes, it's usually like time, temp, anything else special. 95 minutes at this and that, whatever the temperature inside the fume hood was. You don't have to say the fume hood again, because nowhere in this list so far have you talked about removing the chamber out of the fume hood. So we started by saying we prepared this thing in a fume hood. So if you're not saying that you've removed it from the fume hood, I'm assuming it's still in the fume hood. So there's no reason to say that this was run in the fume hood. We already know it's there. The chamber's in there. Okay. Any good scientist knows to check the progress of their experiment. So you don't need to tell your reader that you did that too. They're going to assume that you did. They're going to assume that you checked the progress along the way. So if you have something like checking every 15 minutes, and you don't need to add that. That is a detail that is not appropriate for your audience. It's appropriate for your lab notebook, because if you want to do this again and you're kind of inexperienced, you might say, okay, well, let me think. How many times did I check it last time? So you'll need that information, but it's not a lab report piece of information. Okay, let's see what else. Okay, so you run the experiment for approximately 95 minutes at some degrees Celsius. Well, we talked about this last week, but how do you really know? Like some people's may go 95 minutes, some people's TLCs may last the whole 2 hours. Some people, I don't know, maybe they're really lucky or their solvent's extremely crazy and capillary action strong that day. Maybe it just goes for an hour. So what is the actual visual indicator that tells you, oh, time to stop? Okay, great. So, this happened for 95 minutes, or until the solvent, until the solvent reached some measurement from the top. Okay. All right. So even if a scientist is like, okay, do I have to wait 95 minutes? The answer is no. They say, okay, so it's not really the 95 minutes, but that gives me an idea of how long it's going to take. Because what if my lab's a little bit warmer? Maybe that might happen a bit faster, or maybe I'm doing it in the fridge. It's going to take longer. So really what I'm looking for is I want to run it until the solvent reaches almost the top of the sheet. They did it until it was about 1 centimeter from the top. That's how I'm going to do it too. Okay. Once this happens, then the reaction is done. So you pull the TLC sheet out of the chamber. And what very important thing better you do before you let it dry. Okay, so I have 2 opposing answers here. So I need people, I know that this workshop is longer than most labs, but I need you to keep participating or I'll just log off for the day. I know how to write reports. I don't need this. Okay, so this is something we talked about last week. You definitely have to mark the line of origin. Why did we talk about that last week as something important? That's because you need that position so that you can actually calculate RF. But that's not the only part that you use to calculate RF. The other part that you need, or the other location on the sheet that you need, is the final solvent front, because you need to calculate how far the solvent front ran. So if you just take that TLC sheet out and dip it in anhydride, you will have no idea where your solvent ran for each of your samples, and then you'll have to start this whole thing over. So that actually is an important piece of information, and you have to announce that it was done. Otherwise, you're presenting possible uncertainty, like they didn't even mark the solvent front. They want me to believe their RF values. Not going to happen. Okay. So this solvent front was traced. So far, we're not using very many words like thens or next. Every so often you can throw it in. We're not using firsts, second. We're not explaining things. I'm telling you, this part is the boring part. It's just like, this is what happens in chronological order. And if you don't do it, you could be screwing up your data. This is one of the things that if you don't add it, you're going to introduce doubt in people's mind when it comes to your data. Now, what everyone said is, some people are saying spray. That tells me you didn't watch the video. Some people are saying bathe. That tells me you watched the video. Okay. So sometimes you have to make day of decisions. You have to troubleshoot. Just like I have to troubleshoot. You can see in the background, I have another computer ready to go. Not ready yet, but I had trouble with my computer today. You got to think on the spot. I don't have a sprayer in the lab. What do I do instead? Okay, I'll just put it in a bath. Can't be that different. Okay, so whatever happens in the video, like in terms of me doing stuff, that's actually what happened. If you said that you sprayed the sheet, you're lying. You're lying to the scientific community. No bueno. Okay. So, and I look for these details in the report. Okay, so please do pay attention to what's going on here and do watch the videos. You think I like going into the lab with a mask on by myself and record these videos of my dumb self? No, so please watch them. I do them for you, okay? Bathed, soaked, dipped, whatever. 5% anhydride in butanol for some sort of seconds. I don't think it was on the order of minutes. So you can just look at the YouTube time bar and see how long it was. If it was a couple seconds, you can just say approximately 5 seconds, 30 seconds, approximately a minute. This is going to be an approximate thing. I think more for molecular and cell biology, a lot of the to-dos, like the lab stuff, really like the time you may have like these things and do it for this many seconds. That's people forget, like, oh no, it's fine, it works. Chem, not so good. Oh, not 5%, definitely not. Oh my God. Thank you. Definitely not 5%. Okay. Great. And I still haven't said anything about removing it from the fume hood. So if I'm a new scientist, I'm imagining all this stuff happening in the fume hood, which is in fact the case. And so once you took it out of the bath, now we have to dry this again. And so this time the drying protocol is different. So the TLC sheet dried, or if you dried it a special way. So just tell me, in order, chronological order, how did you dry this TLC sheet? Okay, hair dryer for how long? You can give me approximate time, that's fine. Okay, so I will call that approximately 2 minutes. Okay, great. And then, thanks, Ella. Then, so here's the word then. We do use it. It's not prohibited. You just don't say then. Okay. The sheet was dried with a hair dryer for approximately 2 minutes, then incubated for X number of minutes at X degrees Celsius. Okay. If you were presented with a range, like let's say maybe at some point it was 50 degrees and then maybe you checked at other times and it was 60 degrees, you can say between 50 and 60 degrees Celsius because that's exactly what happened. Okay. All right, but Do you have to do it for 10 minutes or the same way? Where is it? Yeah, the same way we talked about here. Yes, we did it for 95 minutes, but was 95 really the magical number, or were we actually looking for something different? And so at least up here, we were waiting for the solvent to reach approximately 1 centimeter from the top. So the minutes and the time in the incubator, it's kind of a little bit arbitrary. So what we're really looking for, you can even use the same phrase, until spots are fully developed. Boldly. Okay. That's really the important piece of information for the scientist to know. So they maybe don't have a 54-degree incubator, they only have a 37. So they'll probably think in their head like, okay, well, they did it at 10 minutes for 55 degrees. I'll probably need to do it about 20 minutes at 37. So let me just check along the way. But it gives them an idea. Okay, now you've got this sheet with these bold spots on them. And now it's time to get the data, organize the data, and analyze the data. And that's basically what you're sharing next. Here's how I got the data, or here's what I did with these spots. So let's do that. How did I say? We'll just call it data. You all know. All right. If you've already defined RF in the introduction, I know it seems redundant to do it here, but here's where you want to define it as an actual, like, if you're writing da, 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 here's where you're going to have it kind of in the middle of a paragraph, something like that. So you can just say the RF value for each spot. Okay. Because it's not each amino acid, it's each spot. Not only the amino acids, but also the spots in the supplement. So it doesn't matter what kind of spot it is. For all spots, the RF was determined as ... and then you have your actual ratio here. Okay. This one's really easy. The expectations tell you exactly what to say. All you literally have to write is the color of each spot was also observed and recorded. You're not saying what you do with the colors, that you're organizing them into different categories or hues or anything like that. You're not going into as much detail as saying like you're taking your pencil and determining what the circle is and finding the center of the circle. You're really not doing any of that because it's kind of implied. People know that if you're looking at spots, you're going to take the center of the spot. No one takes the top of the spot, no one takes the bottom, no one takes the right. You just kind of find it's the average, right? It's the average thing of the spot. That's going to be the center of the spot. So colors observed and recorded. And since you had to take a picture of this first, you can actually say, you can mention that photograph or image was captured, something about a photograph. The TLC sheet was imaged, the TLC sheet was photographed or something like that with phone, whatever phone it was. That's it. That's your experiment from start to finish. And that's it. From that point, the scientist's like, cool, I know how to set it up. I know how to run it. I know how to get the data. And then I'm going to now read about their data. Sochi, what's your question?
What ranges and colors should we put? Like, do we have to be accurate as in like, do we put red, orange, yellow, or just like red, brown?
That's up to you and your group, but colors, specific colors don't go in the material methods. You literally write the color of each spot was observed and recorded. I am not asking you to say, we observed red colors and purple colors and orange colors. That doesn't go in this place.
Okay, thank you.
Any other questions? So on the note of colors, you don't want to provide so many color options that you only have one amino acid in each group, right? So you want to have, I don't know, just 4 to 6 max, something like that. Because if you had, like, let's say you had 10 different color possibilities, you're definitely not going to see a trend. There's only 20 amino acids. But you don't want to just have 2 colors. Like, the colors are definitely more than just red and orange. There's different colors on there. So it's kind of up to you and your team and how you name your colors. So some people like to say like Merlot, some people like to say Burgundy. I don't know. It's up to you. It's up to you. All right. Any questions on the method section? Okay. So again, this, if you write it the way that we have it here and very concisely, this should have double spaced or 1.5. Double space should be no more than a page and a quarter, and that's pushing it. That's like, I'm gonna probably work on being more concise. I don't think anyone, no matter how good of a writer you are, is gonna get this in less than half a page. So I would say somewhere between half a page and a page is pretty average. Okay, so 1.5 spacing, sure. It's more for like in person because I would grade them because they're hard copies. Online, it doesn't really matter because I'm reading it from the computer. So I like it visually is a little bit easier to have 1.5 spaces. Thank you for the question. So yeah, stick to 1.5 spacing. That's good. Okay. Except for your references, those need to be single spaced. Except for your figure captions, those need to be single spaced. If there are no more questions, I'm going to stop all this. Now, here's what you have to do now. Everyone went to a breakout room with 3 to 4 people. Is that right? Let me check it out. 4, 4, 3. Cool. People are leaving lab. Sweet. Okay. So okay, so if you're in room 1, we're just going to go through this. So get your ears ready because I'm not writing this anywhere. You just need to listen. What you're going to be doing now is you're going to be peer reviewing. After we've just talked about this stuff, you definitely can provide some really great information and feedback and suggestions for the introduction and the method section. Now you have to peer review the whole thing. So you need to also provide feedback on the results, the figures, and the discussion. And so this is going to be due, when do I have it due? I'm gonna look it up right now. Okay. Okay, so I'm going to actually change this. I had it due today, but since it's already 1:30, I want to give you a day to do this. So I know that Canvas, and I'll change it afterwards. I know that Canvas says today at 5, but what you're going to do is turn it in tomorrow by 5. So let me go ahead and share these instructions for you because I hope that I made them as clear as possible because there are some issues here with Google Drive and people not knowing how to share them with people. So I'm going to give you an assignment, but let's say room 1, I have Sierra and Stanley. Sierra, unmute yourself. Tell me, did you write your draft with Stanley?
No.
Okay. Stephanie, did you write your draft with Xochi?
No.
Perfect. Okay. So Sierra and Stanley, you're going to peer evaluate each other's drafts. So what Sierra, you're going to do is, right, as soon as you log off, and I will be able to know because you're going to share it with me too. So if I don't get this from you, that means you didn't do this when you logged off. As soon as we log off Zoom, you're going to make a copy of your draft. This is for everyone, so people should be listening. Copy of your draft. That copy you're going to share with me, my pipeline address, and with Stanley. And you're going to give us editor privileges, not viewer privileges, because then we can't make, I'm not going to make comments, only Stanley is, but I have to also be an editor so I can see the comments. Okay, Stanley, you're going to do the same thing. Stephanie and Zochi, you're going to switch with one another. So before I start delegating the rest of the groups, are there any questions on the procedure of how to share your document with one another? Okay, so you got to peer review it. Once you're done peer reviewing it, you're going to get the Google link, and that's what you're going to turn into Canvas. Okay, with that link, and because I have access to it, I just click the link and I can see everything I need to see. Okay, any questions on the procedure? Tomorrow by 5. I'm giving you an extra day. Typically, I just say this is due today. Okay. All right, cool. Room 2. I have Ella and Layla. Ella, unmute yourself. Tell me, did you write your draft with Layla?
No, I didn't.
Okay. Kelly, unmute yourself. Did you write your draft with Aiden?
No.
Perfect. So Ella and Layla, you are going to peer evaluate each other's reports. Okay. Kelly and Aiden, you're going to peer evaluate each other's reports. Okay. Room 3. At the start of lab, did you only have 3 people in it? Carla, yes or no?
Yeah.
Cool. So Carla, did you write with either Hayden or Nathaniel?
No.
Great. So you're going to do a 3-way switch. So the 3 people of 3, here's how it's going to go. So Carla, you're going to share your report with Hayden. Hayden, you're going to share your report with Nathaniel. Nathaniel, you're going to share your report with Carla. Good? And me. Don't forget me. Okay. Okay. Let's go room 4. Alana, can you unmute yourself and tell me how many people did you originally have in your room?
We had 3 people originally.
Okay. Did you and Nadim write your report together?
No.
Okay, perfect. So you two are going to switch. Sorry, I'm getting a pen. You're going to peer evaluate each other's reports.
Okay. Grace was also in our group, but her Wi-Fi cut out.
Grace Frost or Espinoza?
Espinoza, and I wrote mine with her.
Okay. Okay. Well, I'm hoping that people who have left will email me and I'll figure it out with them. But thank you. Thank you for that information. Okay. Room 5. I have Eiley and Caleb. How many people were originally in your room?
It was just us 2.
It was just you 2. Interesting. Okay. Did you write your report with each other?
No.
Perfect. So you are going to peer evaluate each other's reports. Okay. Finally, room 6. I have Carlos, Diana, and Luis. Let's go with Carlos. Can you unmute yourself? Did you write your report with either Diana or Luis?
No.
Sweet. Okay. So group of 3, we're going to do a 3-way rotating switcheroo. Carlos, you're going to share your report with Diana. Diana, you're going to share your report with Luis. And Luis, you're going to share your report with Carlos. Okay, and me. Everyone and me. Okay, and then that's it. Awesome. So, all right, so everyone knows how to do it. You know how to switch. And then the thing that you're turning in is not your peer-reviewed report. It is the report that you did the peer reviewing on. I'm grading you on your evaluation. I'm not grading you on, oh, look how good their thing was reviewed. I want to see the types of feedback, suggestions that you're providing someone else. So you should be providing the link of the report that you peer evaluated. Questions? Okay, awesome. I know it went late today. There's very few of these that go as long as they do, like this one, but I feel like it's Well, I hope, I hope it's of value for you. And I will see everybody. Thank you for the computer patience with me in lecture and the beginning of lab. And I hope that my computer is now perfectly charged. So I don't know what's happening here, but thank you. Have a great day. We share a copy, right? A copy. First thing you do, make a copy. So you have your original and you have one that people can mess with and you can kind of compare and contrast. Yes, a copy. Any other questions? Alrighty. Have a great day. Good job, everybody, and I'll see you soon.